Okay, folks, some sample problems now dealing with warranties and insurance. Okay, so let's see what we can come up with here. Z-score tables are going to be helpful for us. In Canada, the average cost of vehicle repairs after an accident is $4,250. Okay, so when they say the word average, I think mu. So we've got a mean of $4,250. Standard deviation, sigma, is $1,500. Okay. What is the probability that the repairs to a car will cost more than $6,000? So $6,000 is our data value here. And we want to know what's the probability that it's going to be greater than that. So it's going to be find our percentage and then subtract from 100. So our Z-score first is going to be 6,000 minus 4,250 divided by 1,500. So let's see what we get when we put all that together. So 6,000 minus 4,250, I think, is going to be 1,750. And then we have to divide that by 1,500. So let's see, 1,750 divided by 1,500 is a Z-score of 1.17-ish. So about 1.17. Okay, so there's our Z-score. Let's go to a table, which we already saw here. So we want a positive 1.17. So there's 1.17 on our table, and that takes us right here. So it's 0.8790 already. So let's take a look. We end up with a percentage of 87.90. So 87.9% of the vehicle repairs are going to be less than that, because remember the table tells us percentages to the left. So the ones that are going to be greater than that, or more than $6,000, will be 100 minus 87.9, which I think is going to be somewhere in the vicinity of 12.1%. And the number over here that most closely matches us is the probability, and probability is at a 1 instead of at a percent, so 0.12. Alrighty. Gaming consoles typically last 5 years before requiring replacement. Okay. If this is the mean lifespan, so the mean lifespan is 5, and the normal distribution has a standard deviation of 2 years, good stuff to have. For what length of time should the manufacturer set the warranty if they are willing to replace up to 15% of the consoles they manufacture? So we want a 15% replacement. Okay, so if we only want to replace 15%, then what we're going to have to do is we're going to look for a Z-score in our table back here that is a 0.15 for a Z-score if we want to replace 15%. So let's see, if we're replacing 15%, then 0.15, where are we? Close to this number. Right about, I guess we'll go with 0.1492 and make Christopher Columbus happy. So 0.1492 would be negative 1.04. So we get negative 1.04 there for our Z-score. So, oh, wrong slide, there we go. That means Z is going to be equal to negative 1.04. So we need to find out what X is, and that'll tell us the length of time. So X will be the number of years in this distribution. So it's going to be mu plus Z, which in this case is negative 1.04, times sigma, which is 2. So we're going to have 5 minus 2.08, which looks to me like it's going to be about 2.92 years. So it stands to reason if we don't want to be replacing too many of them, and they last an average of 5 years, then we'll give about a 3-year warranty. And then we'll only have to replace 15% or less. Okay, so somewhere in that vicinity. Hope that makes sense and sort of brings all this stuff together a little bit, but these applications are kind of neat and fun when you get used to them. You see how statistics is used in the real world. So same review stuff as last time. So find your allowable percentage to get your Z-score, and then use the Z-score to determine the value of X when you're doing a warranty problem, and for an insurance problem, find your Z-score and then use the Z-score to find the percentage to get the correct probability. Okay, thanks very much. Hope that helps.